Welcome back. We have the B part of the question number 5. So, what is the non-deterministic Turing machine? A non-deterministic Turing machine is a theoretical model of computation that extends the capabilities of deterministic Turing machine. Unlike a deterministic Turing machine, which has a single transition from each state for each input symbol, NTM can have multiple possible transition from a state for a given input symbol. So at each step, a computation and NTM can explore multiple possible computational paths simultaneously. Finally, an NTM is defined as 7-tuple, where Q is finite set of states, summation is the input alphabet, and the phi is the transition function, and Q0 is the starting state, QA is the set state, and Q reject is the reject state. Deterministic Turing machine (DTM). A deterministic Turing machine is a classical model of computation where the machine's behavior is determined by the single transition of each input symbol in each state. What is the linear bounded automata? A linear bounded automation is a restricted form of Turing machine where the tape is bounded by the input size. In LBA, the tape head cannot move beyond the boundaries of the input string. LBAs are equivalent in power to Turing machines but are more restricted in terms of their tape usage. So, moving to the question number 6, give two examples of each of the following. So, first, a decision problem. Example number 1, the halting problem. Given a program and its input, decide whether the program will eventually halt or run indefinitely. Example 2, the traveling salesman problem. Given a list of cities and the distance between each pair of cities, find the shortest possible route that visits each city exactly once and returns to the original city. Optimization problem. Knapsack problem. Given a set of items, each with a weight and a value, determine the subset of items to include in a knapsack so that the total weight is less than or equal to a given limit and the total value is maximized. Example 2 is maximum flow problem. Given a network with capacities on its edges, find the maximum amount of flow that can set from a specified source to the specified link. Undecidability. Example 1, post correspondence problem. Given a set of dominoes with a string written on each and determine whether there exists a sequence of these dominoes that can be arranged such that the strings on the top and the bottom match when read in order. Example 2 is decision problem. Determine whether a given statement in first order logic is universally valid. This is famously proven undecidable by Gödel and Turing. Fourth is P and NP. Example 1, primality testing. Given a number, determine whether it is a prime number. Second is integer factorization, NP. Integer and given an integer, find its prime factors. Fifth is NP and NPC. First example is Boolean satisfiability. Given a Boolean formula, determine if there is an assignment of truth values to its variable that makes the formula true. Example 2 is subset sum problem. Given a set of integers and a target value, determine whether there is a subset of the integers that sum up to a target value. Sixth is recursive language. Example 1, the set of all palindrome over the alphabet 0 and 1. Example 2 is the set of all even length strings over the alphabet 0 and B. We will cover the question number 7 in our last video. So thank you.